Make sure you're on this side of the classwork. Barry has a 71 in bio class. I'm going to do these 3 with you, and then you're going to do the 3 on the back for classwork. So I'm going to start. If at any point you feel like, oh, I got this, you can just pause and get ahead of me and then just play the video at double speed and just check your work, right? All of that is fine. So do what works for you, but I'm going to go through, and I would suggest that you at least watch the first one all the way through so that you see what the expectation is for the problems. Barry has a 71 in bio class. He goes to office hours to get extra help, and he brings his grade up 2 points each time he goes to office hours. Write an equation for his grade. Okay, so we're going to identify the dependent variable y, the independent variable x, the rate of change, and the starting point. Okay, so you've already had some practice identifying the rate of change and starting point, so you might right away see like, oh, well, his grade is going to start at 71. And then each time he goes to office hours, it's going to go up 2, right? So you might already see like, okay, this is going to be positive 2, this is positive 71. So what's the independent and dependent variable? Well, what's causing what to change? So first, like, let's think about the 2 things that are changing, right? One thing that's changing is his grade, right? Like his grade in the class is changing. And the other thing that's changing is like, what's causing his grade to change? Because grades don't just magically change, right? They have to be changed by some action. And so what's causing it to change is he's going to office hours, right? And so listen to the words I'm using. If this is causing this to change, then remember the independent variable causes a change in a dependent variable. So in this case, the independent variable is office hours. This is what's in Barry's control. He can choose to go to office hours or not to go to office hours, right? And then the dependent variable, the thing that gets changed based on whether he goes to office hours or not, is his grade. Okay. So the equation, right, and we don't necessarily actually really need to fully understand this to write the equation, because the equation is always just y equals the slope times x plus the starting point, right? So we could have written the equation before, but now we really need to know this in order to answer these questions. Okay, so here's my equation, right? I have a starting point of 71 and a slope of 2. And so what will Barry's grade be after 6 office hour sessions? So first thing, I'm going to copy the equation. And the question is, where does this 6 go in my equation? Well, 6 is the number of office hour sessions. So which variable represents office hour sessions? Well, let's look up here. The x represents office hours. The x represents the number of office hour sessions that he goes to. So I'm going to plug in 6 for x. Bring everything else down. And the question is asking, what will his grade be? So we want to know, what will his grade, what will y equal after 6 office hour sessions? So we just do the math. 2 times 6 is 12 plus 71. And 12 plus 71 is 83. So his new grade will be 83. Now, here it says, how many office hour sessions has Barry gone to if he gets his grade up to a 91? So again, we're going to copy the equation. And this time, where do we plug in the 91? Well, that's not number of office hour sessions, so it doesn't go for the x. That's his grade. So come back up here and say, okay, well, where do I plug in his grade? Well, I plug in his grade for y, because y is the letter that represents his grade. So you plug in 91 equals 2x plus 71, right? And then what we want to know is how many office hour sessions. What is x equal if his grade is 91? So now I'm going to solve for x. So how do I get x by itself? Start by subtracting 71 from both sides. 91 minus 71 is 20. Divide by 2, and I get 10 equals x. So how many office hour sessions? Well, x is the number of office hour sessions, so how many? It's 10. 10 office hour sessions will get his grade up to a 91. Okay, let's go on to the next one. Now, a great thing to do is if you want to like read this problem first and see how far you can get, and then press play, that's a really great thing to do to push yourself. Kathy is a repair technician for a phone company. Each day she's assigned to fix 91 phones. She fixes 13 each hour. Write an equation for how many phones Kathy has left to fix. Okay, so let's see. She starts each day with 91 phones to fix. That's her starting point. Then she fixes 13 each hour. And we want to know how many phones she has left to fix. So if she starts with 91 and then she fixes 13, then she has 13 less to fix. So the rate of change is actually negative 13, right? Because after an hour, she has 13 less phones to fix, then 13 less, then 13 less. So the rate of change is negative 13. Okay, so what are the two things that are changing here? Well, definitely one thing that's changing is the number of phones left to fix. And then, so when is that changing? Or like, why is that changing? Or how is it changing? Well, she fixes 13 each hour. So the other thing that's changing is like how many hours have passed. Okay, and remember, we don't even have to think too hard about this one because we know that time is always an independent variable, right? So hours is a unit of time. So we know right away, hours is going to be our x, the independent variable. And the number of phones left is going to be our y, our dependent variable. Because hours passing can't be affected by anything, right? The hours will pass no matter what. And then the number of phones left is impacted. Okay, so my equation based on my rate of change in my starting point, y equals m x plus b. So let's copy my equation here. I know I'll need it. After how many hours will Kathy be done for the day? 0 phones left to fix. Interesting. Okay, so there's the 0 phones left to fix. I'm going to plug in the 0. Which variable represents phones left to fix? The y. So I'm going to plug in 0 for y. Right? This is what is x, how many hours have passed if the number of phones to fix is y. Oops, and I wrote 19 here, but it's 91. Okay, so let's take a look. I noticed that I have 0 on one side and I have like a variable and a constant on the other side. I like to work with positive numbers, and I noticed this 13 is negative, so I'm going to just add 13x to both sides. And I end up with 13x equals 91. And then I divide by 13. And I get x equals 91 divided by 13 is 7. And so after how many hours will Kathy be done for the day? After 7 hours. And you can even like, right, we can strengthen our answer a little bit by writing 7 hours. Right? And we knew it was hours because when it said x equals 7, we can look up here. Well, what does x equal? It equals hours. So if x equals 7, it has to be 7 what? 7 hours. Okay. How many phones will Kathy have left after 3 hours? So again, and this time we're given a number 3, and it's 3 hours. Where do I plug in hours? X is hours, so I'm going to plug in 3 for x. We want to know how many phones she'll have left. So this is 13 times 3 is 39, and it's negative times positive, so it's negative. And this is basically 91 minus 39. 91 minus 39. So you can do it in your head, otherwise check it on the calculator. 91 minus 39. Did you get 52? I don't know. Okay, and it's 52 what? Well, it's 52. What is y equal? Y equals 52, so 52 must be the number of phones left. So 52 phones left. Okay, and I'm going to do one more. So if you would like to start it and try it on your own, this would be a good time to pause. Jackson is starting an exercise program. The first day he'll spend 30 minutes on a treadmill. He'll increase his time on the treadmill by 2 minutes each day. Write an equation for the number of minutes he exercises. Okay, so right away I see he's going to start with 30 minutes right on the first day. So that's his starting point. And he's going to increase his time by 2 minutes each day. So he's going to add 2 minutes. That's the rate of change. So already I can write my equation. And then what are the two things that are changing here? What's the independent and dependent variable? Let's see. So the amount of time he spends on the treadmill, right? And then what's changing that? What's changing the amount of time he spends? Well, he's increasing it by 2 minutes each day. So the days pass and he increases it by 2 minutes. Okay, so this is a little bit like, I don't know, maybe confusing because I said time was independent. It seems like there's both of these are time. But this is, but the thing about which one can be changed, right? Which one can he change? Can he change the fact that days are passing? Or can he change the amount of time he spends on a treadmill? Well, he can change the amount of time he spends on a treadmill, but he can't, like, the days, those pass, and there's nothing you can do to impact the days passing. And so the days passing has to be independent because they don't depend on anything. So the days passing is independent, and then based on the amount of days that have passed, it impacts the time he spends on treadmill. The time he spends on the treadmill. Time spent on treadmill. All right, here we go. Y equals 2x plus 30. How long will Barry spend on the treadmill after 2 weeks? Okay, so what's weird is this says 2 weeks, but my x is days, so I can't just plug in 2 because I have this is days and this is weeks. So how many days are in 2 weeks? Well, in 1 week there's 7 days, so in 2 weeks there's 14 days. So this question is asking the same thing as if it said, how long will Barry spend on the treadmill after 14 days? Well, that I know what to do with. X is days, so I'm going to plug in 14 for days. 2 times 14 is 28 plus 30. 28 plus 30 is 58. So how long will he spend on the treadmill? And it's 58. Well, what is it? What's the unit of time? We could even write it here. It might make our lives a little easier. It's minutes spent on a treadmill. So this is 58 minutes. If Barry runs an hour on a treadmill, how many days has he been with his program? Okay, well, this time it's the time that he's spending on the treadmill that we're given, right? An hour is the time that he's spending on the treadmill. So what should we plug into? We should plug into y, because that's a minute spent on the treadmill. How many minutes in an hour? 60 minutes. So this is 60 minutes on a treadmill. We want to know how many days he's been running. I'm going to solve this for x. Substitute. 30 equals 2x. So in order to get x by itself, I'm going to divide by 2 on both sides. 30 divided by 2 is 15. So if 15 equals x, what is x? X is days. So it's 15 days.